from this website. Yeah, so far we studied about the pumps. Now we are going to study about the fan. A fan is a device that adds energy to the fluid, typically the gas, for the purpose of the moving air. Okay, so it basically adds the energy by the static pressure, if you remember, and the velocity pressure PV. If you remember, the total pressure is static pressure plus velocity pressure. Static pressure is the static pressure is PS plus velocity pressure is rho V square by 2, if you remember from the pitot tube. So that's what the fan is adding, both the pressure to the air and also add velocity and move the air through the system. And where do we use the fan for? For drying, basically to reduce the moisture content of the material to a safe moisture content so that you can store it for a longer time. And that is going to be the focus of this class. You can use the fan for ventilation too, heating and cooling. You can use the fan for pneumatic conveying. Basically, you fluidize the particle and move the particle from one location to another location using the air. You can also use the fans for sorting and grading. So basically, if you have like a grain and the chaff, if you're blowing the air based on the density, you can blow the chaff away and then you can keep the grain. You can keep the grain. Like we said, we studied pump before and now we are studying fan. What's the difference? Basically, the pump moves the liquid, whereas the fan moves the air or gas. Okay. So what's the difference between the fan and a compressor? The compressor typically operates at a much higher pressure, whereas the fans we are going to consider operate at a very low pressure. For the purpose of the fan, we are going to assume that the air is incompressible. What does mean is the density do not change. So in Bernoulli's equation, the density is not changing. So you can use the form we studied in the Bernoulli's equation before. So that's what we are going to do it. If it isn't compressor, you cannot use the Bernoulli's equation we studied before. The density keeps changing between the point 1 and 2. So in case of the fan, the density do not change. Okay. So there are different types of fan. The two major types we are going to study are the axial fans and the centrifugal fans. In case of the axial fan, the inlet to the air and the outlet to the air along the axis of the fan or the blade. Whereas in a centrifugal fan, the air comes and then leaves perpendicular direction. So we will look at each one separately. The axial flow fan, the three major types are propeller fans, which is almost like a fan in front of a helicopter or like a plane, turbojet plane, or that's the fan typically used for ventilation typically. There are two other fans, the tube axial and the van axial. The propeller fans are basically, here you can see a fan that's swinging. Here is a motor that is spinning the fan. It basically moves a large volume of the air at a very low pressure, less than 2 inches of water. So the examples are the ventilation fans. So if you have an animal housing, the whole objective is to move the air as much as you can. There is no pressure resistance to move at all. So the advantages are it is cheap. The disadvantages, it is very noisy. Okay. The tube axial fan, basically again you have a propeller fan, but you have a tube, it placed inside the tube. It lets it operate at a little higher pressure. And typically the blades have a very close tolerance to the housing. In case of the vane axial fan, it provides a much higher pressure than the tube axial, and there are some vanes you can see here that guides the air through the gradual turn so that it can increase the pressure significantly. So the tube axial and vane axial are the one most commonly used for grain drying, and their pressure is around about 4 inches of static pressure. The main disadvantage is it's noisy. The centrifugal fan is the another category of the fan. In this case, the air enters and leaves in a perpendicular direction. So let me look at the first graph here. The air is going through here, and then there are blades inside. As you can see, the tolerances or the gap increases. The air comes in and it's driven out this way. So compared to the air coming in and the air leaving, it's perpendicular or normal. Therefore, it is a centrifugal fan. We also call it as the squirrel cage fan. A lot of time people call it a squirrel cage fan. Okay. So this is the centrifugal fan. Yeah, here it is, the squirrel cage fans. So the air enters parallel to the shaft, exit perpendicular to the shaft. This is much quieter. The advantage is that it produces a much higher static pressure, but it's typically more expensive. Okay. So there are different types. One is a forward curved blades, and they have a large number of blades, and they are limited to clean air. If it is a dirty air, the dirt is going to get accumulated on the forward facing. And it produces a static pressure of around 10 inches of water. The straight blade, because it's a straight blade, it can handle the dirty air. It has a fewer blades. The backward curve is also not for the dirty air because it can accumulate, and it has a fewer blade, and it gives a much higher than 25 inches of static pressure. So if you remember, the propeller fan is less than 2 inches of water, right? And then we had like a tube and a vane axial fan is around 4 inches of water, whereas this one is 25 inches of water. The forward curved is about 10 inches of water, and the backward is around up to 25 inches of water. Okay. So these are most efficient and they are most expensive because they can offer a very high static pressure. So for grain drying, we typically use either the tube or vane axial fan, or typically the backward or the forward centrifugal fans. Those are the most common. The propeller fans are typically used for the ventilation purposes. The cross flow or a tangential fan, if you look at that, if you go to a grocery store, you have like a refrigerator section where the meat and everything is stored. If you see, there is no window at all. There is no door at all. So are we not losing a lot of energy? Actually, what they use is, they use what is called as a tangential fan. Basically, it blows a sheet of air. People call it as a air curtain. and it continuously blows the air, and it basically prevents the cold air to leave the freezer section. So next time when you go to the grocery store, try to insert your air, feel it. There should be a air curtain typically done by the tangential fans. So the kitchen hoods are tangential fan, air curtains, and those things are used. The mixed flow is like, you can say it's a ray inline or axial or a perpendicular. So it's mixed with both. Okay. This is not very common. So if you look at the pump curves or the fan curves, if you remember, the fan curve is the flow rate Q in CFM, which is nothing but feet cube per minute or a meter cube per second. And the static pressure is typically, if it says inches, it's inches of water, or in kilopascals, or meters of water column. If you look at here, the axial fan applies less pressure, but it has a high flow rate, right? Whereas this high-speed centrifugal, it can offer a much higher static pressure, but much lower flow rate. So you have like you look at the fan curve, you look at the application, how much is the flow requirement for your application, and how much head it has to overcome, which we calculated earlier. And if you know that, you can easily calculate it. And that concludes the introduction. Maybe let's go one more time. So can you identify the type of the fan? This is a centrifugal fan. The air is going into the center and then it's coming around. Whereas this is the axial fan that goes along. So the left side is axial, the right side is the centrifugal fan. So let's stop this.